Hey guys, Mr. Vickery here, physical science class. We're going to talk about acids and bases today. You just got done completing a lab in which you investigated some of the properties of acids and bases. You probably have a pretty good idea when you look around you what types of substances make acids, what types of substances make bases, and maybe some of the things that are considered neutral. Today in this video we're going to investigate what actually makes something an acid, what makes something a base, where you can find them, and what do they do. I want to start you off with a short video I found on the web in which they take a strong acid and a strong base and react them with pop cans. So let's see what that looks like.
What's being generated over there in the acid can. Oh my word. We're going to show you something with aluminium today. And the thing is, we've got here Coke cans and Pepsi cans as well, so that it's fair. But when Neil gave them to me, I had a look inside, and you can see there, this one has quite clearly rusted. So these Coke cans are made of aluminium, whereas the Pepsi ones are steel. That's why we can only use the Coke cans to do this next experiment. So what we're going to do with these is to show a property of aluminium and how it reacts with both acid and with base. And that means it's a substance that's amphoteric. What we're going to do is we've got a solution of sodium hydroxide, that's our base, and we've got also hydrochloric acid, and then Neil's going to put the acid in and I'll put the base in at the same time, and we're going to see what happens to the aluminium cans.
Yep.
Go. Oh yeah, straight away you can see the bubbling there with the base. Clearly you've got a very vigorous reaction in both cases. So what's being generated here is sodium aluminate. And what's being generated over there in the acid can, oh my word, is aluminium chloride and water. We expected reaction with both, yeah, I hadn't anticipated to be quite so vigorous. I hadn't expected it to be quite so, wow! That is brilliant. So this is obviously a very vigorous, hot reaction. You've got a lot of fumes being given off, which is a good job why we did it in the fume cupboard. You can see all that smoke being drawn up into the extraction fan. I honestly thought the acid would have done more damage. Because when you think of acid, you always associate acids as being the evil guy of the chemical world. I think those Pepsi cans have gotten off very lightly. They may have had their tops cut off, but they've met a fate far better than the Coke cans here. Good old Pepsi for making them steel. Neil, can you clean that up for us? What's left is just the plastic around the outside of the can. All the metal's been converted to sodium aluminate. And that one's still going. The acid is still eating away at that can. And again, it's just leaving behind the plastic coating. It was a really exothermic reaction. And I didn't think I would actually see a can bubbling away like that. That is just incredible, isn't it? It looks pretty disgusting.
So what in the world makes those acids and bases strong enough to where they can eat a pop can as quickly and as violently as they did? Imagine your eyeball getting a drop of that in there. I mean, that's why we make you wear goggles. So some of the properties, and you probably noticed this when you're doing the lab, but acids have a very sour taste. Now you might ask, well, you're not gonna taste acids, which is in the chemistry lab is true. You're not going to take hydrochloric acid and give it a taste, but if you were to, you would get a sour taste in your mouth. But there are plenty of things that contain acids, like all your fruits, like strawberries, grapes, oranges, apples, all contain citric acid, so you do taste that sour taste right there. Some of the other things to note, when you put a metal like aluminum, which you saw in the video, aluminum pop cans, into acid, you get a very violent reaction, and it actually produces hydrogen gas, which is explosive. Another interesting thing that you see on this list is that acids are great conductors of electricity. In fact, in a car battery, they have sulfuric acid as one of the main ingredients. It helps conduct electricity and reacts with the lead that's in that battery so it can produce electricity. Bases are a little bit tougher. There's not near as many examples in the around you that are bases. If you were to taste one, they have a bitter taste. How can I describe the difference? I really can't, but you'll know it when you taste it. If you were to get a little base on your finger, such as soap, for instance, it has a slippery feeling. Bases are also great conductors of electricity. So here's some of the common acids you're going to see. A lot of these we saw in the lab, but your citrus fruits, um, tomato juice, apple cider vinegar, grape juice, toilet bowl cleaner. But what actually makes an acid? If I look at, I gave you a quick list of different chemical compounds. I want you to take a quick look. Here we have citric acid, which is in your citrus fruits, carbonic acid, which is any carbonated beverage, ascorbic acid, which is vitamin C found in your citrus fruits and in some of the other foods that you eat. Hydrochloric acid is your stomach acid and found in toilet bowl cleaner, different concentrations, of course. Acetic acid is what's found in vinegar. Take a moment and see if you can see anything at all that looks the same in these 5 common acids. Hopefully you noticed in each case, right here we got some hydrogens, 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 one hydrogen. Here's one hydrogen here. What makes an acid is some type of a substance that can produce the hydrogen ion in solution. So if I have a beaker of water, my beaker's not a very good drawing here, and it contains anything that makes hydrogen ions, this substance is now an acid. Make sense? So it really doesn't matter what the substance is, as long as it produces this H plus, which is called the hydrogen ion. You write that down. Hydrogen ion, H plus. Then you got yourself an acid. There's varying strengths. Of course, vinegar's not going to melt a pop can like you saw, but if I got it concentrated enough, maybe it could. That's also what gives you that sour taste when you bite into a lemon. Bases, we didn't see it as many as I'd hoped in the lab, but here's some of the common things that you'll see as a base. Ammonia is a strong base. Drain cleaner, which you can see here, contains a strong base called sodium hydroxide. And what you've seen is that bases are just as nasty as acids. And here's some other common ingredients. Now, bases are a little bit trickier. They don't have this hydrogen that's produced, but one thing that they do produce in solution is this guy right here. We call that, and you're going to want to write this down, hydroxide ion, which is also known as the OH minus ion. Anything that produces this in solution is considered a base. You might ask, how does ammonia produce the hydroxide ion? In a beaker of water, when you put the ammonia in, it actually will take one of the hydrogens. Let me see if I can get this off that water, adds it to the ammonia, producing something called NH4 plus, and leaving you with the hydroxide ion. That's a little bit complicated for what we're doing, but just know that when you see hydroxide, it means base. This gives you a kind of a table of, if you were to test the pH, what's considered an acid, what's considered a base. Water, right here in the middle, is at 7. That's neutral. Anything acidic is below 7. Got some examples. The lower the number, if I have several examples I could pull out of the lab that are at 0, the stronger the acid. So battery acid will eat your clothes, eat your skin, eat your eyeballs, just about anything it touches. On the other end, equally as nasty, you get things up in the 13-14 range like drain cleaner. They're super strong base and can do equally nasty things to you. But you can see some basic compounds. Bleach we saw, household ammonia we saw. We did not see milk of magnesia, but seawater, human eyes, milk are all in this basic range. An interesting story, and I'll try to keep this short because I want to keep this video short. When you react a strong base like you saw with the Coke can and a strong acid also like you saw with the Coke can, they actually neutralize each other and they produce a common substance called H2O, water. And another common substance, sodium chloride, table salt. So in essence, I take two really nasty compounds, sodium hydroxide, hydrochloric acid, mix them together, and I get two things that you experience in your everyday lives, water and table salt. Interesting story, and you'll like this. I had a professor once who told me a story, he didn't do this, of a professor at college that would, every year he would mix up a certain concentration of sodium hydroxide, a certain concentration of hydrochloric acid. He would mix them together in two different beakers, mix them together into one, which would make, in essence, salt water, and he would take a drink of it just to prove that the acid and the base neutralized each other. It worked very successfully for several years. The last year that he did it, he was off on one of the concentrations. So one of them was too strong or stronger than the other, mix them together, and he was left with still a very concentrated acid or base. One of these two. And you saw what they do to pop cans. Can you imagine what it would do to your esophagus if the acid went down? Severely burned his esophagus all the way down into his stomach, and now you know why that was the last time that that demonstration was performed. Last thing I'm going to touch on, being this is physical science and we want to understand how the acids and bases affect the earth. If you think about 10 miles down the interstate, we have that big power plant, it used to be called IPS, I'm not sure what they call it now, Mid-American. They burn coal to produce electricity. Couple of the byproducts are some sulfur oxides, we call them, and nitrogen oxides, which are gases that go up into the atmosphere. Turns out when those two gases react with the water that's in the atmosphere, in the clouds, they will produce two extremely strong acids, nitric acid and sulfuric acid, Granted, they're pretty low concentrations, but when those rain down over here onto things made out of brick, things made out of marble, things made out of metal, as you saw demonstrated earlier, what do you think happens to those items? Over time, they corrode, they melt away, and that's why we have such a problem with acid rain in certain areas, especially if they make a lot of their buildings out of marble or granite or anything that will react with these acids. Let me know if you have any questions going forward and enjoy the quiz.